Okay, so here we go. A scatter plot is a graph used to determine whether data has a relationship, basically. And it asks you to plot the points below and determine whether there's a positive, negative, or no correlation between the data. Now, we've not talked specifically about positive, negative, or no correlation, but I think after you guys plotted all of those points, you should be able to tell me, just by the vocabulary, what kind of correlation this has. And what did you guys think? Positive. Why positive? Yeah, if you wanted to put some more points on this graph, you could predict that they're going to keep going up and to the right. Okay, so from left to right, just like you read a book, the data is going up. So that is a positive correlation. Okay, next section says draw a scatter plot with the given correlation. So now we want to draw one with negative correlation and no correlation. Okay, and it doesn't have to be exact. Let's just draw or sketch the first quadrant of a coordinate plane, and if we want a negative correlation, the data should be going down. So it should look something like this. Okay, and it could be going down more steeply or less steep, but as long as the data is going down, it has a negative correlation. Now, a no correlation would not be going up or down, and it could be just kind of random on your coordinate plane. If we move on to the scatter plots that they've provided for us, it says, given the scatter plots, sketch a line of best fit for the data and tell whether the data has a positive, negative, or no correlation, then write the equation of the line. Okay, so a line of best fit is exactly that. You want to draw a line that best fits the data. So it's going to kind of represent the data. It's going to go through kind of the middle of the data. And so for number one, if we just look at that data, will it have a positive, negative, or no correlation? It's going to have a negative correlation because from left to right, the data is going down. That is also going to be represented in the slope of the line that we write. Okay, the equation of the line is going to have a negative slope. So M is going to be negative, and then we're going to have a B. But before we can find what the slope is and what the y-intercept is, we have to draw a line of best fit. So use a straight edge. If you have, there's some rulers scattered about on the desks. If you need another ruler, there's some up here. Or you can use your ID. You can use a side of a folder, whatever it is, for a straight edge. And draw in a line that you think best represents this data. For number one, draw in a line that you think best represents this data. Okay, so yours may or may not match mine exactly, but it should be close. It should go through about the middle of the data, okay? And now we have to approximate the slope. So look on the line that you graphed, not necessarily my line, but the line that you graphed, and try to find some nice points where it would cross about at a grid line, okay? So what do I mean by that? It looks like my line crosses at about this grid line and about this grid line, but not exact. It actually looks like it crosses almost right here too. You only need 2 points so that you can do rise over run. So use your line to find 2 nice points to find your slope. So my slope would be -1/2 if we did rise over run, rise 1, run 2. Use your points to calculate the slope rise over run. And then the B is the y-intercept, and it looks like they're counting by 10, 10, 20, 30, 40, 50, 60, 70. About where would you say the line of best fit is going to cross the y-axis? Does yours cross at 60? Okay, perfect. But mine crosses a little bit higher than that, not quite at 70, so I'm going to say that my y-intercept is 65. But if yours is 60 or 62, go ahead and write that down. Whatever your line crosses at, write that down for your B. Now you have an M and you have a B, so you can write the equation of the line. Y equals -1/2 x plus 65. That is the equation of the line of best fit. Try number 2. Okay, so again, your line might not match mine perfectly, but it should be close to the same. This one has a positive correlation because it's going up. So when we find the slope, you should have a positive slope. Go ahead and find 2 nice points if you've not already done so to find your slope. My slope, I would say if I found 2 somewhat decent points, would be about 2/3. Rise 2, run 3. And I think my y-intercept is between 5 and 10, so I'm going to say it's at about 7. So the equation of my line would be y equals 2/3 x plus 7. How'd you guys do on that?
What if I got y equals because I got a 1/1, and then I got a multiple from second to 0?
You started at the 0,
Yeah.
and you did 1/1. Looks like that would be okay. Okay? Looks like that would be all right. Okay, try number 3. So it looks like my line's going up just a little bit, not as steeply as the other one, so we've got a positive correlation. If I look and find some nice points, it looks like my slope is going to be at about 1/3, 1/3. And my y-intercept is at about, I don't know, 39. It looks like it crosses right below 40. Yours might be a little above 40. That's okay too. So y equals 1/3 x plus 39. Okay. So now if you flip, it says use the table to complete the following. You are going to use that table to plot the points, sketch a line of best fit, and write the equation of the line of best fit. So all the stuff that we've just done, but you have to plot the points first and do all of it. Okay? So go ahead and try that. Okay, so I plotted those points and I sketched my line. I found a couple points that gave me a slope of 2/3. Actually, I'm sorry, that should be 3/2. Rise 3, run 2. My mistake. And a y-intercept of about 2.5. Okay, so let's look at these follow-up questions. It says, if the data represents the number of hours you study per class you take, label the axes accordingly. So we are going to label the axes with information about the hours that you study and the classes you take. So the number of hours and the number of classes. Which one is going to go on the x-axis? Hours or classes? Classes, right? So the number of classes and then the number of hours is on the y. Bless you. So if you take 1 class, you study 3 hours. If you take 2 classes, you study 5 hours. So then it says which variable is independent and dependent, which axes do these go with? Well, which one depends on the other? Which one depends on the other? The hours depends on the number of classes. So this is dependent, and this is independent. So independent goes with x, and dependent goes with y. And then it says, if you were to take 12 classes, about how many hours would you expect to study? So you're going to plug 12 in for which variable? X, and you're going to solve for y. Try it. So I plugged in 12 for x, and I got about 20.5 hours if I took 12 classes.